Good afternoon, physics. Today in class we talked about objects that move in circles, and we learned that we can take their tangential velocity and solve for their centripetal acceleration using that quantity. What we didn't exactly get to talk about, though, is where does that tangential velocity even come from? And so that's what this video is going to cover so that you can complete the practice on page 45. Okay? So what the notes tell us is that if you're moving in circular motion, uniform circular motion, you go around a circle. And if you think all the way back to geometry and you think about how we measure the circle has a radius in the middle. And then if I measure this distance all the way around the circle, this is called the circumference. And the equation you learned for the circumference is 2 times pi times r. So if I want to know how long the circle is all the way around, all I need to measure is the radius right here, and then measure it times, or multiply it times 2 pi. So that covers this piece right here. The other piece that we need to know is what's called the period. Note, this is big T, not little t. So big T is the period. Okay? Now, period is a new vocabulary word for us, and it also is not on the reference sheet. Okay? But it is kind of intuitive. If I want to know the period, which is just how long it takes something to go all the way around the circle one time, what I do is I measure the time it takes to go around multiple times. So let's say I go around the circle 10 times, and I do this in 5 seconds. So this is 5 seconds. This is 10 trips around the circle. That means it takes me only 1/2 of a second to go around the circle each time. So if I go around one time, 1/2 second, 1 second, 1.52, 2.53, 3.54, 4.55. 10 times in 5 seconds. Okay? It is important that you put the time on top and the number of revolutions on the bottom. Once we have the period, we can plug it in right here, and that gives us our tangential velocity. So if we think about this, circumference is basically the distance that we cover, and period is the time that we cover the distance, because remember, period is how long it takes to go around one time. Distance divided by time, we've seen before, this is basically the same thing as velocity. So even though tangential velocity looks like a whole new equation, you can see it's really just a different way of writing our original velocity equation. So let's take a look at a practice problem that uses this equation. And I want to actually look at practice problem 2. So we have a donut hole attached to a fishing line, and it's being spun around a circle with a radius of 2 meters. It takes 2 seconds to go all the way around the circle. So we have our donut hole on the string. I'm not sure why we put it on a string instead of just eating it, but that's the way it goes sometimes. And so I know that it takes 2 seconds to go all the way around the circle. I also know that this radius is 2 meters. So if I want to find the tangential velocity, I'm going to use my equation from the above. I'm going to take the circumference of the circle and divide it by the period. Now this problem is really kind, and it tells us that it takes 2 seconds to go all the way around the circle. So that already is my period. It also tells me my radius, which is 2 meters. And so I get tangential velocity is 2 pi, or since pi is 3.14, it would be 6.28 meters per second. So that's the tangential velocity. Next, I want to know the centripetal acceleration of the donut hole. So we're going to go back to our old equation, which is vt squared over r. Notice r shows up again. So we're going to say AC equals 6.28 squared divided by r, which was 2. And And so my centripetal acceleration, give me just a second while I calculate it. And again, feel free to plug this into your calculator. I am not at all expecting you to be able to do all of this in your head. It works out to be 19.72 meters per second squared. Okay? So we use multiple equations. We also have to be able to reason through this up here. For the rest of the practice, you need to complete problems 1, 3, and 4, remembering that there is this relationship between period and tangential velocity, and tangential velocity and centripetal acceleration. So you can go in either direction. Tomorrow's entrance ticket will have a couple of these problems, a couple of these problems, and a couple of these problems on there. So just be ready for that. Have a great rest of your night.